Hello everyone, welcome to a fresh lecture on signal processor components. This is Dr. Anirban Dasgupta and let's get started. So far we discussed the components in signal processing where we had sensors or ADCs or DSPs and then other things like memory and other stuff. But here we are more focused on the components of the signal processor, like what is inside this big signal processor. And you can see this diagram. So there are a lot of things and well, you may find this very complicated, and those who have done a course on computer architecture might find this relatable, but let's see a summary of what is this. So first thing is, like in Harvard architecture, as I said in the previous lecture, so it has a separate program memory and data memory. So what is program memory? It is the set of instructions, like say if I do convolution, so it will be written that so convolve this and this, then convolve this and this, then add this and this. So this set of instruction is in program memory. Also you need to load the data, that load the data from here, and this is the data. This is actually where the signal segments will be stored. Then we have buses. Now what are buses? So buses are basically which carries the data. Like in real world we say buses carry the passengers. So similarly here buses carry the data and address. So you see there is a data bus which is bidirectional, like from the processor to the memory as well as from the memory to the processor, and address bus is one way. It is just giving the address location. And there are control buses also, which is not shown here. Then there are something called data registers. So data registers are somewhere where we store some intermediate results. There is something called instruction cache, which will basically store the recent program to be executed or the recent instruction to be executed. There is something called address generator. Here you see there are two address generators. Then there is a dedicated multiplier which will do faster multiplication. Then we have split ALUs in DSPs where each ALU can operate in parallel. There is a MAC unit which is not shown here, but MAC unit typically refers to multiply and accumulate. There is a barrel shifter which is like a circular shift, and there is a watchdog timer which will reset the processor if there is some problem or issues in the processing unit or operation. So coming to program and data memory. So program memory is used to store the program, like you write the code in the computer and then click on run or execute, you have connected your DSP. So that code goes as binaries to the processor program memory, and this is typically non-volatile. That is, I may be wanting my DSP to work as a single kind of a operation. Say it will just do filtering of voice signal. So here my program is typically stored and it should not be changed or erased. But now often these have also become like volatile and you can often rewrite the program and change it. But when you actually make a final product, like say this recorder which is recording this lecture, it's probably the program is hard coded in a non-volatile ROM. Then data memory is for storing the temporary data, like signals which are coming and going and which are changing after time to time, and this is typically volatile in nature, and it has to be because it is changing. So whenever the DSP is powered off, you lose all the information unless you store it in a permanent drive. So these are the three buses which I was discussing. So address bus is unidirectional from the processor to the say memory or the peripherals, and this carries the addresses. And what is address? Basically, like if you want to find my space, so that is typically an address. You have to find my room number and then which department and something like that. So, that is address, and that is the role of address bus. Data bus is bidirectional. So, because I can send data to and fro, I can take the parcel and I can also return a parcel. So, that is data bus, that is bidirectional. And then there is a control bus, which can be bidirectional as well as unidirectional, and it is basically managing the control signal, that now you have to write or now you have to read, something like that. So, read is one way, writing is another way, but the control bus will like basically coordinate or manages the control signal. So, this is the data registers, which are like very small, and these are fast storage locations. Now, register is for storing immediate results, and like for example, say I want to do convolution. So, I would require immediate data. So, I will pick up the data from the data register, because they are very near and the access time will be less, and in this way it will not take much time to fetch data from somewhere in memory which is quite far away from the processor. So, data registers can be of different types, like general purpose registers, and these are used for temporary operations like storing input values, output values, immediate results. Like for example, if this is a filtering operation, so the filter coefficients and your input signal values which you are going to convolve can be stored in your general purpose register. Then there is an accumulator. Accumulator is basically storing the output of the arithmetic operations. So, in one way it is behaving like a GPR, like for convolution. So, you have to multiply two things, then add, then again multiply, add. So, these immediate results you can store in the accumulator. Then there are some special purpose registers like the program counter, which holds the address of the next instruction which is going to be fetched. Now, these instructions are fetched sequentially typically. Then there are status registers that contains flags that represent the results of most recent operation, and then like say there is a output 0. So, you can have a flag 0 which is 1, that means there is a 0. Then there can be divide by 0 flag which can also indicate 1, there can be a carry flag, overflow flag. Now, if you want to read more about this, you can go and check out some microcontroller or microprocessor course where these will be given in details. Then there are pointer registers which are used for managing pointers to memory locations like stack pointer, base pointers. Then index registers, which is used for storing the index in addressing modes. So, I can access the index of arrays or buffers. Then shift registers, which are used to perform bit shifting operations. This is very interesting, which is the instruction cache. Now, cache or instruction cache is a small fast memory located within your DSP. Now, let me give you a very good analogy to understand this concept. So, say you have a book rack, bookshelf, many people have, that is very nice, and you have all your course books, like you have your signal processing books, your control system books, your embedded system books, and what else, say image processing books. And say you are studying, and when you want to study signal processing, or say you have your signal processing exam tomorrow. So, will you take out all the books from the rack and keep it on your table? No, but you would prefer to have all the signal processing books on your table, because that is what you will need the most. So, if you keep them back to the shelf every time, and then every time when you want to read again get it back, that will waste a lot of time and energy. So, rather you keep it on the table, because you know that you will be frequently accessing that book, and that table is basically your instruction cache. So, it will store the recently fetched instructions and frequently used instructions. So, in your phone also you have often seen this term cache memory or clear your cache. So, that is basically your cache. Now, when your table is filled, you can now clear your cache so that you can have more space to keep more things in the cache memory. So, this is how you improve the speed and efficiency by reducing the time it takes to access instruction from slower main memory, which is your book rack. And now when the cache becomes full, so basically you have to clear the cache, but unless so you replace with a new one, so the DSP will decide that what to do. Then address generator. Now address generator is a specialized hardware which is responsible for calculating the memory address dynamically. Now one is memory allocation, like suppose you make a big building or a big flat and you want to number them, so you can number them sequentially. And then allocating address, say you have a department and there are some offices filled and some are empty, so you want to allocate, so you have to search for which addresses are empty. So that is how you can allocate this address. So and then the addresses can be like mapped in a very smarter way and in a faster way. So if you have multiple address generators, because each data unit needs to be stored in some location, right? But there has to be which location it has to stay, that has to be very clear. Like students who are staying in a hostel, so each of them are allotted some room, right? And how this allotment is done, maybe in a lottery system, maybe in some sequential manner, but somebody has to do that allocation. And that if the number of rooms are high, like 500, so it will be very difficult for an individual to locate all the rooms. So if you have multiple such allocators, that will be faster. And many DSPs have multiple address generators. So you will receive some base address as the starting point in memory, and then it can compute the offset or index, like this is the first room, the base room, and then there are these many already allocated. So what should be the next address where I can send it, and it will incrementally calculate the next memory address once you have been allotted a space. So it can also support indirect addressing. Now what is indirect addressing? Suppose you want to find say an address, say I want to find that okay, this villa, this Prakash villa for example. So where is this Prakash villa? So you ask someone and that person will say that okay, after 4 blocks that is Prakash villa. So that is direct addressing, directly you are finding the location. Indirect addressing means say you do not know the location, but you know who knows the location. So you should say sorry, I do not know where is Prakash villa, but if you go to Raman villa, say the guy in Raman villa knows where is Prakash villa, because that Raman villa guy is friend to Prakash, Raman is friend to Prakash. So if you go to Raman villa, I can show you that is 2 from this row. So that way you are doing indirect addressing. The next is dedicated multiplier. Now of course you know what is multiplication. Well, you studied in your very young days or childhood days, I would say, that multiplication is repeated addition. Like if I want to multiply 16 and 16, I add them 16 times, right? So add, then store in the accumulator, then again add, and do this until I reach the figure 16. And that will take 16 clock cycles if I do them sequentially. So dedicated multiplier does it something in parallel so that you get the result in 1 clock cycle. And that is this specialized hardware for doing multiplication efficiently at high speed. And this is typically consisting of array of logic gates that can handle fixed point and floating point operation depending on the DSP design. So the DSP can be fixed point design or floating point design. If you are not sure what is fixed point or floating point, so say if you have 8-bit register, so I can store 0 to 255 considering all are integers. But if say there is something in the negative, say I have something in 0.5, then in the integer part I can store something from say 0 to 127, and the last bit I can use it for a fractional part, like is it 0.5 or not. So this point can be placed to, so this is called Q format, Q 7.1. Then if I use 2 for decimals, then Q 6.2. So these are Q formats. Now if this is fixed, like always it will be 7 places of integer and 1 places of this decimal, then this is called fixed point. And if I can adjust or vary this point based on my operation needs, that is floating point. The next is split ALU, and the split ALU says that, so ALU are basically what it is doing the arithmetic and logical operations. So, arithmetic operations you know, plus, minus, multiply and divide, and I would say this is divide, and then you have your logical operations which are OR, your AND, your NOT, and also comparison like greater than, less than, equals to. So, ALU does arithmetic and logical operations, and if you have multiple ALUs, then your processing can be speeded up, provided the operations are not sequential, they are independent of each other. So, that is the work of a split ALU. So, split ALU can do the arithmetic operations and then bitwise operations like AND or NOT and XOR, and in this manner it can efficiently handle different data streams, and this is beneficial in multi-threaded environments. Then the MAC operation or the multiply accumulate operation. So, what it does is basically, so it combines this multiplication and addition. So, in many operations in DSPs, first you need to multiply and then add to the accumulator. For example, if I have 1, 2, 3 and 4, 5, 6, and if I want to do a convolution or say a dot product kind of a thing, so what will you do? You have to multiply 1 into 4, then add this result to 2 dot cross 5 plus 3 cross 6. So, first I will calculate this and say this is my accumulator. So, multiply and accumulate. Then I will multiply this and then add it to the accumulator. So, this is A plus new A, and then this whole thing becomes my accumulator now, and then I multiply this and then this whole thing is added and this becomes my new accumulator. So, any dot product operation can be done in a MAC format. Now, you see multiply and then accumulate 2 clock cycle, multiply and accumulate 4 clock cycles, multiply and accumulate 6 clock cycles are wasted. What if I can do it in 1 clock cycle? So, that is the speciality in a MAC operator, which can do this MAC operation in 1 clock cycle, or it is like a parallel dot product. Now, why this is used in DSPs? Because in signal processing we are doing a lot of operations which are in the dot product form. For example, convolution. So, if you see convolution, what are we doing? We are having a kernel and a signal which is just changing, shifting. Then the next, say if say this is my kernel and this is my signal, and say I shift this, then in the next I shift this, next I shift this, next I shift this. So, efficiently if I do zero padding, I am doing what? I am doing the dot product. Or even if you see this as a matrix operation which I had shown, so again you multiply this row with this column, then this row in this column. So, each is a dot product operation, and using the MAC operator you can do this faster. So, convolution and correlation are very similar things. FFT also, if you see, I am having this DFT matrix and I am having this signal. So, this also is using this dot product kind of a thing. And coming to barrel shifter. So, first if you recall your digital electronics class, so you have studied shift registers, and what is a shift register? It is a sequential circuit, and in 1 clock cycle it will shift 1 bit. But barrel shifter is a combinatorial circuit, and in 1 clock cycle you can get your desired amount of shift, something like this. So, you look at this truth table, you can understand. So, if I want a shift of 3, so this will be giving me a shift of 3 directly in 1 clock cycle. If I want a shift of 1, it will give shift of 1. So, this is how the bits are changed. This is a combinatorial circuit. This is nothing but a decoder circuit where I can give the shift count, and that shift count will be decoded, and resulting shift you will get. So, this is like shifting a barrel. So, barrel, you know, this is like a circular shift kind of a thing. So, this is basically about the barrel shifter, and then finally, we will discuss about another component which I said is the watchdog timer. So, watchdog timer is like a watchdog or a security guard. So, which will monitor if the processor has any malfunction or not. How will it check a malfunction? So, whenever, so it knows that at this time it should have send me a result. If it does not send me a result, then there is something problem. It is like you tell the security guard that if I do not come out in say 1 hour, then there is some problem. So, you just check up on me that whether everything is fine or not. So, it does similar thing, like it will periodically send a signal to the processor to indicate whether the system is working properly or not. And if it is not receiving any such signal, that means it will send some problem is there, and it will send a reset signal, so that the processor is reset within a set time frame, and the operation will resume like it had got a automated reboot. This often happens to our computers when we get an automated reboot often, because see, there is a system crash or something. So, this is the pictorial representation of a watchdog timer. Thank you so much. So, we will meet again. Have a nice day.